Hey guys, welcome back to the live stream tonight. Got a good video here. Going to catch up on a couple things that we're working on. So let's just hop right into it with our little presentation here to tell you what is going on. So let me update this. We've got audio tonight. For some reason it went out last night. I have no idea why. But we're just going to get all caught back up. So yeah, if you're joining us tonight, we're talking about the power system. We're talking about troubleshooting it. Kind of had a good problem. Something that I can share with you guys that it may help you in the future if you're dealing with a electrical issue and that's something that's acting kind of funny. You might be getting an error code, for example, and although the error code says check this, it actually could be a symptom of something else. So that's what we're going to talk about tonight. And that is with this Frigo fridge. So this is the one that Thomas has in his van. And it is a drawer-style fridge. So 2 drawer style. It's a very nice fridge. And yeah, it's been doing great. However, there was a little error that came up. And it was after he had lost the power in this van had gotten below a certain threshold. It must have been lower than about 60%, or something like that. What's interesting is if you're using a lithium iron phosphate battery system, you can go much lower than a regular lead acid system and not damage the batteries. So even though at 67%, where this little thing happened, you have a lot of power left. So come to find out, we're bringing the van back in these next few weeks because we're putting on the solar. We're doing some other add-ons, as you guys can see throughout the live streams that we're doing. So what I did was I said, I'm going to take the fridge out and I'm going to turn it off completely overnight so all the codes can clear. If that's even a thing with these fridges, which it is, they do clear. And then what I did was I turned it back on. I had the van power system on, and I let it run just for days on end. It's been running constantly in freezer mode, which means the top drawer is a freezer and the bottom drawer is a freezer. And I was really putting it through the paces, just letting it run 24/7. I would open the drawer and then shut it, just let that cold air out and have it keep working. Well, for a solid week, nothing happened. No error codes. The coldest setting. So the first things right off the bat, power seems to not be an issue at the moment. The ventilation, because the error had to do with an overheating of one of the systems. It was an E3 error. And then, everything else was just was working fine. So what happened, so I took it off of the shore power. So we have a shore power connection in the back of the van. So if you go right here to the back of the van, you'll see at the top of this is the Manager 30, which is, if you look on the very right-hand side, you're going to see 3 components. You're going to see the bottom right is the ARB compressor. Above that is the new MPPT charge controller that we've installed. And then to the left of it, that long black box is the Manager 30 from RedArc. It contains the DC to DC charger and the MPPT controller is built in as one unit. On the top of that unit, there's essentially like a computer plug, like an IEC cable is the technical name. And that's where you plug in to do shore power, because it's not typical that you're going to do shore power all the time. So when it's in the shop, I plug it in there just to keep the batteries topped off so I don't run into the fan turning off while I'm working on it, so I can have lights inside and stuff like that. Since we've got it to the point where all that stuff is in the van. So what I did is I just let the system kind of die out. I unplugged the shore power, and over the next 2 or 3 days, I just let the battery percentage go from 100 all the way down to 80, 70. And then right before I left the shop, I heard the refrigerator beeping. I was very excited that it was beeping because I had created a situation to where something got exposed, and that was this low voltage. I meant to put this picture up on here. I'm just going to have to show you on my phone. But the voltage that it started to get unhappy at was, let's see if I can find this. Yeah, 12.7 volts. So when the system got to 12.7 volts, it fired off the low battery alarm on the refrigerator. So not the error code of something overheating, but it was the battery alarm. Well, made a note of that. Then I hooked the system back up to shore power, noted that it was at 67% for the power. So it was 67% battery capacity, which that's a ton of power. You still have a lot to go. Noted that when the system came back on and came to proper voltage, hey Jamie, when it got up to proper voltage, what I found was that an E3 error came up on the screen of the refrigerator. So not only did it have the 12 volt, now it has 12 volt and it goes to E3, but E3 is not 12 volts. So I'll kind of fast forward through this if you guys are not interested, but the point is the low voltage created the E3 error on this type of refrigerator. Now, there's nothing wrong with the refrigerator. As far as all the troubleshooting guys that were sent to me going through that whole process, the fridge is fine. So what's happening is that particular fridge on hard freezer mode, it doesn't have to be freezer mode. Whenever the voltage gets below 12.7, the alarm is going to go off, and it may create that error code in the future. So I'm going to bring this to the attention of Frigo. I'm not sure if they'll warranty it and move on, but in the meantime, the fridge is operating as normal, like it did for the last week or so. So now there's something that you don't want to have happen, but at the same time, finding out the root cause of what's causing it will help you, because if it's something that you can't get support on, which we purchased this through Panther RV, and they've been very helpful. They're all ready to go in case the solution doesn't, fix itself. So we've been in communication, but they're great. So there's no problem warranty-wise or like getting it fixed if something actually is wrong with it. But let's say you're in a situation where you didn't have a good situation. You bought something, there's no support, nobody's helping you, and you need to find out what the problem is, because you're probably going to have to fix it yourself. So herein lies the title of the video. So what I did was I went to the power system, let it go down, the error code came up. Okay, so that was all in one nutshell. But in the back of my mind is like, I need to check my part of the system, so not the fridge. Let's see if there's something other than the batteries just getting to a certain level that may be causing this. So in a van, in the back of the van, you've got your batteries and your power system. So one thing that you need to make sure there's a priority is the next thing on our list right here. So that is top balancing the battery. So what does top balancing mean? I'm going to briefly explain what it is, but below here there's a YouTube channel called DIY Solar with Will Prouse. I'm sure a bunch of you guys have seen his channel and have watched his videos. So on his channel, wait for this ad to go away. So in this video, he talks about, now he's making his own battery systems in some of these videos. And one of the first processes that you have to do is you have to make sure that the cells are balanced. I think there's two different ways. Don't quote me on this. This is he's an expert as far as understanding how to do this. He builds these systems all the time. But you can top balance it or you can bottom balance it. Whether it's draining the batteries all the way down and fully charging them from the bottom up, or topping them off at the top, which is what I'm talking about, which is a top balance. And what you can do is each of the individual cells, you're going to put on a charger and allow it to fully absorb that charge and get topped off essentially. Now you need to do that for every cell. So for example, in this video, he's got a bunch of cells. He's making some big old battery. But these cells that he's actually looking at in these videos are the same. There's, I think, 4 of these type of cells in the SOK battery. One of the benefits of the SOK battery is it's one of the lithium iron phosphate batteries that it's fully serviceable. So inside that metal case, you can open it up, you can remove the BMS, and then the individuals, there's 4 cells, and you could, if one goes bad, you could take it out, put a new one in, put the battery back together. It's pretty cool. Unlike a Battleborn, which it's sealed for life, you can't get in there if something happens. So there's always pros and cons to that. But I wanted to, I top balanced the batteries before I put them in Thomas's van. But between me putting them in, the charge cycles that were going, that the van has gone through with the last couple months, I just wanted to make sure that something that I did was not affecting this low voltage and maybe like a connection or something like that. So I went through and I went into the van, and that's where we're going to go to this next part of the video. So check out Will Prouse's channel. I've got the name of the video. It's right here. It is How to Top Balance Lithium Iron Phosphate Cells Quickly and When You Need to Do It. So I'm going to let him take it from there as far as the details. But we're going to go over here where I have voltage check. Let's hop in the van, and I'll show you what I did just to make sure that how I put things together in the van was doing good, for lack of a better word. All right, so let's move over to the other camera. You guys let me know in the comments. Audio should be perfect. There should be no problem with audio, but just in case there is, just always just let me know. All right, so checking that on the phone. Okay, we're in the back of the van. Now, as the live stream's growing with people watching this, if you've not been in the back of this van, I'm just going to do a really brief intro of what we have here. So we've decided to go with, on this build for Thomas, we needed to have a wireless power system, something that had an app where he could control all the devices on his phone instead of having to go to light switches, touch them, all that stuff. Plus, it's just cool to have it on your phone. So I've been to a couple of shows over the last couple of years, and one company I really enjoyed checking out, this was at an Overlanding Expo event, was the company Red Arc. So they're based out of Australia, but they have distribution in the U.S. and customer service and people here. There's one actual local in Charlotte. I don't think it's a brick and mortar, but it's it's a place where you can connect to people. There's humans. If you have problems, you don't have to worry. You don't have to wait until you're on Australia time to connect for certain situations. Anyway, the Red Arc is a pretty beefy system, and we decided to go with it. We have on the front side, you've got 5 10 amp sources that you can up to 10 amps of power. that are wirelessly controllable, and then on the back side you've got 5 more that are up to 30 amps worth of current that are controllable on your phone. Behind that system, how we're distributing the power from the batteries. We're using the Lynx distributor. Everybody's pretty familiar with the Lynx distributor, I think, and so really enjoy this. Keeps everything nice and organized. It's essentially a glorified bus bar, but it's pretty nice. And then up here we have our 4 100 amp hour SOK batteries. Now, the first thing I wanted to check was I needed to disconnect the mega fuse that I have in there. So I've got a 300 amp fuse. And we'll talk about sizing fuses in a later video. But that fuse is back here, and that is essentially between here and our positive terminal on our battery. And then to connect all the batteries together, we've got a positive 4-aught UL listed cable here. We've made this on our own, so we bought the terminals online, or the lugs, and you really want to, if you can find the UL listed ones, it's kind of hard to, but try to find them if you can. The 4-aught cable, pure copper, pure stranded copper, and then we've got our heat shrink. And then we did the same thing for our negative terminals. And then those are connecting all the batteries together. So what I did is I wanted to take the fuse out, turn the system off, take the fuse out, get it safe, and take these off, these connections, so I could test the system. So this is where this can help you out. So the first thing you want to do if you're having some type of weird issue in a van, start from where the power is coming from, and that's the batteries. Now, my gut was saying it seemed like it was taking a bit of time for the van to recharge. And when I was talking with Thomas, as far as the root cause is the van's not being driven as much as we originally thought. So that's why we're adding more solar. So the time that it's sitting at the house, instead of always having to go pull a cord out and plug it into shore power, we're just going to maximize the sun that's coming in from the sky and just maximize it by just adding as much as we can, so that during the week it's getting topped off, rather than us coming in with the cable and having to plug in the van to top it off. Now you may be asking, well, what's the reason that the battery keeps getting drained? Well, if you have an adventure van, you want to go places. So when you're ready to go places, it's nice to have stuff in the van ready to go, such as the fridge being pre-chilled, being able to put water and stuff in there. But again, having it pre-chilled so that when you're ready to go, you can just throw your food, drinks in there, and you can take off. You're not really having to worry about it getting up to temperature, that sort of thing. So that's a nice thing about having a off-grid power system. But if you kind of get in a weird spot to where maybe you didn't drive it enough, but you're using the inverter, you're really going to have to, you can put everything on paper, theoretical, but when you put it in the real world, you shake the van down, there's going to be things that change. You're going to figure out, oh man, I need to use the inverter and I left it on for 2 or 3 days. Or I had the freezer on in my refrigerator and I didn't drive for a couple days, or it was overcast and there wasn't any sun. So you can have all the nice stuff, but how those systems work as efficiently as possible is what the kind of shakedown run is. That's when you take your van out, go on your trips, write some stuff down that you'd like maybe improved, and then you bring it back just as Thomas did here, and that's what we're addressing. Add as much solar as possible so that the battery anxiety goes away. Transferring stuff like
charging the cell phone or computer off the inverter and moving it to a 12-volt system, like high-powered USB outlet, like USB Type-C, with like a high wattage output, like a 65 watt or something like that. So we did that. That's the plan here that we're doing. But even if that stuff is perfect, we've got our USB charging our laptops. We're not using the inverter. We're saving all this. It doesn't change the fact that there may be something up with the batteries. I know I kind of glorify SOK, but guess what? It's possible that one of these batteries is not communicating something in the BMS. It's not getting a full charge. It's possible. So what we want to do is we want to get our multimeter, and we're going to go through. I know you guys can't see it, but I'm going to go back to my computer, and I'm going to play a GoPro video that I took earlier today, and I'm just going to commentate on top of it because it shows me going through this. So I'm going to just show you. I'm going to check the voltage one more time just because I'm here. And then we're going to hop off, go back on the computer, and then play that GoPro video to explain how we tested this. Yeah, perfect. So we go through, and we're going to test each one of these in that video. And then, yeah, we'll just... I filmed that earlier today, so it'll be fun watching it together because I don't want to talk too much right now because I might actually talk over what I wanted to share with you guys today. But as you guys know,
Put those questions in the chat below. Let me know what questions you guys have. It can be not related to what we're working on tonight. It can be other stuff. It doesn't have to be solar power or power troubleshooting. It could be anything. But hopefully you guys are familiar with one of these. So this is a multimeter. And essentially, it's off, and then you rotate it to volts. And you want to make sure it's DC. So that's direct current. You don't want it on alternating because we don't have alternating unless we turn on the inverter. So we use this to test our system. But before you test, you got to, what are you looking for? How do you know what the number is? So believe it or not, lithium doesn't technically operate at 12 volts. So when you're checking the battery, you need to go to the manuals. So I'm just moving some stuff around here on the computer. Give me 1 second. So something that's funny with what I do is if I try to find information off of a website, so the manufacturer's website, for example, it's usually missing the information that I need. And the only way that I can find that information is if I pull out the manual and look at it, which is weird for troubleshooting because I like to look up stuff quickly instead of kind of looking through a book. But sometimes that you have to do that. And for this case, for example, I went to this forum and I was looking for somebody to kind of ran into the same situation where SOK didn't tell them where the voltage drops to. So when you charge a lithium iron phosphate battery, it usually charges around 14.5, 14.6. Now, when you have a specific lithium iron phosphate charger, it's going to aim for that and then charge at that voltage, which is a little bit different than a lead acid battery because lead acid is a little bit lower. So you got 14.6, and then what happens is it kind of messes with your mind, but that voltage is going to settle. and it's going to settle to it's going to drop to a certain number. So I was trying to find out what that number was for SOK, because SOK won't, on their website, webpage, whatever, they're not going to tell you, oh, charge it at this, and then when you see it, when it rests, it's going to drop to 13.6. Because in order to troubleshoot properly, that 13.6 volts is the information that I need to know that when I read 13.5 on each battery, that everything's okay. So I found this piece of information. So I knew the batteries were okay. What was even better was every single battery was exactly 13.5 volts. Now, when I bring up the conversation about top balancing, something that would have indicated that we weren't having a good power transfer or charging of the batteries is that three of the batteries were at 13.5 and one battery was at 12.8, for example. Then we know there's a problem. There's a problem with the BMS, or there's some problem with maybe one of them has like a bad cell, and it continues to rob power from other batteries. And that's just an example. But so that was what I was looking for. Thankfully, every single battery was exactly the same voltage, and there was no problem. So I'm going to go through, let me go pull up this battery, good Lord, this video. Let's see, I may have to, I think I may have to talk over this one. Let's see. So essentially what I'm doing here is I'm just walking through each part of this. I didn't leak the audio on this, so I'm just going to talk over it anyway. But as far as this goes, everything is fine. I don't have to worry about how the power is coming into it. This is me just explaining exactly what I did in the van. We'll come back to this in a second. So this cable at the bottom here, this one was damaged. It's a communication cable, and it has to do with this, which is the red arc shunt. We'll talk about that in a second, because I thought that might have been a culprit. And I'm talking about the wiring and the Wago connectors, the wireless Dometic awning switch. As you guys know, the theme of this van is there's not a lot of place to put things, and it's very difficult to kind of hide wires. And not only that, these two wires specifically, I wanted to make sure that if I needed to pull them to allow access across the van, I was able to do that. All right, so you can see here that how the batteries are all connected together. I'm going to try to fast forward it to get to the reading of the meter. Okay, so we'll exit out of this one. Let's go to this video. Yeah, so I'm talking about the shunt. So everything is very, very tight in here. We have the shunt over here on the left, and then we get the fuse that fuses the batteries over here on the right. Oh, perfect. So the loading ramp on Thomas's van, a couple of friends were helping, and there's a roller wheel that if you don't lift the gate up properly, it can potentially hit this cable, and the potential became real, and it hit this cable. So I've since moved it up even further. It was about 2 inches above the little roller wheel, but apparently if you lean the ramp out, it can hit it. It can take up the 2-inch gap. So I moved it almost 8 inches, maybe 10 inches higher. So a whole foot higher than the original location. So we should have no problem. Now this cable right here is like a networking communication cable. This is what talks to the red vision, which is the interface panel. And what happened? This got we got smushed, but nothing got broken. None of the wires were frayed or anything like that. It just kind of got smushed. And the charge cycles and everything have been fine. Now again, we have the replacement right here, so I'm getting ready to put it in there. So I was anticipating that it's possible that the batteries were not getting a proper charge. So sometimes the shunt, it might say 100%. And real quick, if you don't know what a battery shunt is, it is on the negative side of the power system before connecting to the batteries. And it allows, it's like it's a terrible example. I don't want to say like speedometer, but it's measuring the flow of electricity. So the flow of electricity out versus the flow of electricity in, and between the out and the in, it's able to calculate the percentage of charge. So you can see if that thing is damaged, not only is it not adequately charging the batteries probably or potentially, it's not showing you the correct value. So that cable needed to get fixed. I haven't installed it because I need to finish the solar and all that. I'll just briefly mention, I took the fridge out because I've got a thermal camera, and I took a couple pictures of this. I just wanted to see if there's any hot spots in the motor or anything like that. I don't repair refrigerators, but I like to know everything that's going on in my customers' vans. I don't want, I want to have the information and make an educated decision on, what step we're going to take next. Are we going to do warranty, or is it, non-issue? Because with the RV industry, in the time that I've done it, or short time that I've done it, you don't want to, what's the point I'm trying to make? You can kind of get into the weeds on things. So things take a lot longer. It's not where you can go to Best Buy and like return your TV, or go to Lowe's and like return a fridge and get another one. You have things shipped to you. Things are in different locations of the United States. So one, you always want to buy good quality and have a good relationship with a distributor or manufacturer, which I try to do my best job at doing, kind of setting up all that stuff. But at the end of the day, it'd be easy to say, oh, the fridge is not working. Let's get rid of it. Let's send it off and like wait for another one to come in. Well, in this situation, I can't get it to go into failure mode unless the power system is below an adequate voltage, which that's not the fridge's fault. The fridge is designed to alarm if the power on your van or your boat or your yacht, wherever you're using this fridge, gets below a certain threshold, that the fridge is doing exactly what it's supposed to do. It's just in our case, we have a power system that can go below 67% and still provide power to the inverter and stuff like that. The fridge is the one of the group that's not going to be happy. So in the event that Thomas is somewhere where, he needs that extra battery juice, what we're going to do is anything below 67% or lower, if he's not using the fridge, we can turn it off, and then we can surpass that and go lower in percentage as far as a situation that would warrant that. For example, he needs to charge the Paragon or something like that. We can turn the fridge off and then direct all that remaining power to finish a charge instead of keeping drinks cold, for example. All right, so let's move on past that. The main solution is just to get more power in the van and always have it topped off at 100%. So that's what we're doing with the upgraded solar. Now moving on to the batteries themselves. Let's hop over here. That's a good picture of the shunt. I did want to make a note here, if Rhetoric ever does watch these videos, but this is essentially a network cable, right? But it's molded into this plastic. So even though the shunt may not be damaged, instead of being able to replace the cable, it's molded in the plastic and you can't replace it. So maybe there's a reason, because of the way the pinout is on here and it's proprietary and specific. That's cool. I understand that. But it would be cool if this was, if you damage this cable, you could just replace it with like a household network cable, just for an emergency purpose. That's all I'm saying. All right. So moving on to getting the power checked. Let's go to the other video. We got our multimeter. So we're going to go through and we're going to start checking the terminals. Now be very careful when you are working with lithium batteries. The current discharge, or any battery, deep cycle, AGM, lead acid, these can discharge a lot of current. And so just be safe. I mean, I've got 80/20 over here. When I work on the system, I actually have a couple of ratchets that I have taped up so that they don't arc. And just take precautions, because you don't want to do some simple little oops and you fry like your wireless controller for your awning, for example. So yeah, just be careful. And the reason we have these wires coming through here is because this is the best location for them for maintenance and future repair if needed. These were all buried behind the sheet metal or behind the batteries. It'd be very hard to diagnose the issue in the future. They're all shielded and they're all, zip tied, cable managed. So if it looks kind of crazy here, that was taken in consideration when using this as the path for the kind of wire highway. So what we're going to do is we're just going to touch both sides, negative and positive. Be careful where you're touching. And you'll notice that it's 13.5 volts. So we do that on each one, each battery, this first one here. And then we got 13.5. And then we got it on the rear, 13.5. And then our last one is 13.5. Okay. So hey, Go and Do. Hope you're doing great. So we've done the fridge troubleshooting. And just for everyone that's just joining us tonight, we're talking about power system troubleshooting, and then also an update on what we've been working on Thomas's van. We've been troubleshooting the fridge. We kind of figured out what the E3 error was. It was being created from the van just being on having low battery. We talked about top balancing the battery, which is essentially making sure all the batteries before we connect them as a group are the same voltage and are fully charged. The video I just came off of was me checking the voltage of the van. And let me move this out of the way. I was checking let me zoom in here. Checking the voltage. Everything came to 13.5. We referenced a forum article that said after it had been charged for 1 to 4 hours, it went from 14.6 to 13.6. So that made me happy. Now we get to battery shunt replacement. So again, if you're just joining, the battery shunt is this device that makes sure that measures the flow of electricity in and out of the power system to calculate your battery percentage and expected time that the battery will die based on the current power draw. So we're going to be replacing the battery shunt. I haven't done that yet because I'm finishing up the solar. And mentioning the solar, let's show you guys what I've been working on. So behind me over here, I'm going to pull up these bars. The 4 bars back here, these are 1-inch square tubing, aluminum square tubing. They've been painted matte black. If you want to paint anything on a van, you want to make sure you use denatured alcohol right here. Clean the surface, buff it if you need to. But paint that I've been using, because a van's pretty harsh on the roof, and I use let's see if I have a can of it. So, not sponsored, but Krylon Fusion All-in-One Matte Black. This stuff is the Krylon Fusion is really good paint, spray paint. If you prep it properly, it does a really good job. Anyway, so these back here, so I made those. The rear ones that are longer are for the rear 50-watt panels we're putting on, and then I've already got one 50-watt panel up on top. But I paused because I like everything that looks super professional, and I went on Amazon and I got these little plastic ends that snap into the end of this aluminum, and they make it look just, again, a professional install is what I'm all about. Plus, I don't want this thing to whistle. I don't want the wind to come across. I couldn't put it this way. I had to put it this way. So I don't want the wind whistling, in the future, that sort of thing. But you can see how nice of a finish this does. And this is just a can of spray paint. Oh, man. That's definitely a loaded question because painting, because it's the pneumatic cooling is a plastic case, right? It's a plastic cover, essentially, on the pneumatic cooling unit. I know which one you're talking about. Oh yeah, let me finish this real quick. Let me put it back down. But what I did is I marked out all the locations of where it goes into the roof rack, and then these holes right here, you get the light, that are towards the edge. These line up with the holes in the sides. You can kind of see this is what's going to happen. So these holes right here bolt in, and then that way you can see it's just a nice professional look. Nobody's going to be up there, but if you fly a drone and you want to look at the top of your van, I want to make sure it's matte black. All right, let me get back to go and do's questions. So let's see here. I think Nova wants to say hi. There you go. I don't know if that's a good idea or a bad idea, because she'll probably want to play now. So if I go to pneumatic, go back to pneumatic cooling. All right, so go and do, you have this unit or one of these. Is that which one you have? So you're probably dealing with this cover. So I know you may have wanted the black one because you have the high roof Transit, right? Now you could paint it, but so now, I'm kind of OCD. I like the things to be all the same, paint matched and everything. But for this situation, the problem is you could paint it, and I think that's good paint. The problem is it's just plastic is a little different, and I don't know because I know how metal works as far as the paint on it. I feel a little more comfortable giving advice on painting metal and prepping it because I do it all the time. The plastic's a different can of worms because the plastics their surface either accepts it or it doesn't accept it. So, if you had to sand it a little bit, roughen it up, put some primer, and then spray paint it black, at the end of the day, if it's a high roof, I don't actually think I would paint it. White's going to give you a slight benefit of it, being cooler when it's in direct sun and not. The system's designed not to overheat, but what I'm saying is it's just that less of heat that is in that the unit's going to be experiencing. So I would say, coming from somebody who likes everything to be matte black and kind of stealth, I may give you the opinion of not painting it. If you really did want the plastic one, I'm sure they'd be able to get you to order the black one, because it's just a cover. It's just a simple cover. I would first try to get the black one if you really love the blacked out look on top. But with a high roof and the roof rack, actually, do you have a roof rack yet? Oh, it's a dark gray van. Okay. All right, I know where you're coming from. Well, see, they've got to be able to get in it, like buy one of these. Just give them a call and see if you can just buy one. Because I've worked with other companies, and for example, I needed one other part either because I, cut it up and I needed another one. Not sure how much they would charge you for that, but yeah, I know what you're saying. If you got the dark gray van, you probably want. I know that sounds high, but that is a reasonable price for the lid in this RV van industry world. I know it sounds high, but that's what I would expect to pay if, say, I'm working on a customer's van and I needed to modify something and I messed up or whatever, and I needed to get another one. Yeah, about $200 is what I guess that was going to be. So, yeah, that's that's my opinion. Probably leave it, but heck, you can try to paint it. They make if you sanded it down and you put a good diffusion primer, it's made for plastics. So it is. Their whole thing is about it paints any surface, metals, wood, plastics. So yeah, just give it a try. If you really mess up, then it's just going to be. If you mess up, it's just going to be $200. I know it sucks. So maybe my advice would be I know it's a different color, but just leave it. Just leave it. See if you can kind of get used to it. Because everybody's going to look at how cool your van is. They're not going to worry that, it's a white AC unit, not a black AC unit. All right. Hope that helped. All right. So we were talking about the battery shunt replacement, red arc, the solar panel brackets, the aluminum ones. So again, something like this is, something that you can make at home. It's professional, looks great. It's cool to find things that are at Lowe's. And for example, this is the bar. So this is the spare from my other van, but this is essentially the Flatline Vanco roof rack. I think they're using a 10 series. It's a double right there. The thing is, this stuff is very heavy. It's very expensive. It takes a long time to ship. And, when you want to get creative and solve a problem, sometimes just a simple square tubing at Lowe's, paint it, get the right hardware. Always use stainless steel hardware. And you're good. You're set. All right. We're going to move into the next part of the video. We're going to talk about the RedArc Manager 30 DC to DC MPPT solar charge controller, as well as the Rover Elite 20 amp MPPT solar charge controller. Not sponsored, no affiliation. I'm just comparing both of these so that you guys can learn what to look for. Now, we did a live stream where I taught you guys how to interpret a data sheet for lithium iron phosphate batteries and how to know the difference between like an SOK, a Battleborn, and there was another battery. I can't remember what it is. Anyway, how you can pick out the difference and justify paying more money or seeing that there's really not that big of a deal and going with more of a budget option. So over here on the right hand of the screen, the top one is our Manager 30. Now we're kind of comparing like a Cadillac to a Kia, although Kias are looking pretty nice now these days. You kind of can't say that anymore. So the Manager 30 is going to be better than the Rover Elite. But that all has to do with your use case. So our use case is we're not trying to power the whole entire van. We're just trying to add an additional, let's see, at the end of the day, it's going to be 3, 6, 9, 12, like an additional 12 amps of power throughout our day that we didn't have before. So in the top right, we have 3 things that I want you guys to look at. The first one is in green here, and that's the rated charge current. So the rated charge current is the first thing to look out for because so anybody can be watching these videos. So if you don't have a Sprinter or a Ford Transit or anything like that, let's say you have like an Econoline or you have a minivan or whatever, the reason that I highlighted this green and that it's important has to do with your alternator. So even though I think the van that I have, I think it's like a 190 amp alternator or like 160 or something like that. Even though you have all of that at your disposal, you got to remember that the car chose the alternator, chose its own battery for a purpose. When you crank up that V6 or you have all the accessory power on a van, you've got halogen lights, you've got the computer system, you got the stereo system, you've got Apple CarPlay, you've got the Ford Sync, you have the lights in the interior lights in the van. Heck, you might even have somebody charging off of the Ford factory installed inverter. So all that has been sized and gone through the engineering process to provide a certain alternator for a van. Now, it's important to not abuse the factory alternator. So go low before you go high on the rated charge current of these DC to DC chargers, because you want your van to act like it's under factory warranty. You know, you don't want to burn up your alternator after you get your van done. And it's like, man, my battery stayed topped off, but I had to replace the alternator because it burned up. Now, I'm not saying this is going to happen to you. There's a lot of wiggle room on these factory alternators. And so my opinion is, I'm going to go look up, I'm going to cross-reference an example. Give me 1 second. I'm looking up the nations. It's a nations alternator, and it's the secondary. Let's see, secondary dual alternator. All right, so I'm going to pop this up on the computer. So we got Nations starter alternator. This is a pretty popular brand for doing this. I know about them. I've not been to this website, so if I click on something kind of crazy, just bear with me. So if we go to a Transit, let's go up to a, let's see, Ford Transit 1919. Okay. So let's just pick the one for Thomas's van, for example. So let's look at our years. What do we have to work with? We got 2020, 2020. This is not one. This is not one. Not one. Nope. Nope. Okay. He's got 3. Here we go. Dual alternator. So I was trying to look for a cheaper one, but look at this. So this dual alternator setup, 2020 to 2022 Ford Transit van, 3.5 liter. The alternator, this is not cabling, wiring, labor, install, just the alternator kit is $2,199. $2,199. You guys can see why I'm doing the streams earlier. It's a little late in the afternoon. Now, guess what? These things are amazing. Because where's the amperage on these things? Yeah, 370 amps. Can you guys see that? 370 amp output. So Thomas has 400 amp hours. So almost in an hour of running this, you could recharge his whole entire van. But when you are, it depends on the RPM, blah, blah, blah. The thing is, there's probably $2,200 that you would want to spend somewhere else in the van. And that's kind of my point. So my point is, start with a system and a foundation that you can, that on paper says, you know what, this is going to be good for my needs. The reason that we are introducing this additional MPPT solar charge controller is we were going to add another DC to DC charger, but we needed to look at the use case for Thomas's van. So is he a full-time van lifer? No. Does he use his van on a weekly, weekend basis? Yes. So that the use case is the van is going to be parked for 4 or 5 days, and then it's going to go on a trip. So it's not going from, park to park to park to park. He's not driving it 6 hours a day to travel the U.S. It's for, weekend competitions, trips, stuff like that. So the van's going to be in the driveway. So instead of having a cord pulled all the way out, let's try to maximize our solar on the roof. We have 4 more spots. Let's just add 200 more watts. That's what we did. So the Rover Elite, so each of those panels cost $60. So $240 for the solar panels, like another $100 or so for the wiring. And then the Rover Elite, it's on sale for $99 right now. So let's just call it $500. there's some more cost. That's not including the tubing and stuff. This is assuming that you can just mount the panels up there. Let's just say the panels and the controller and a couple cables, let's say $500. So for $500, we are going to be able to solve our driveway problem. And we will be moving from 350 watts to 550 watts of solar. So there's one more bonus to doing this. So the bonus of adding a secondary system is redundancy. So let's just say the great Red Arc system, for some reason it stops working. It stops charging the system. Just for some reason. I don't know. Something in the box messes up and whatever. Well, guess what? We have a secondary solar charge controller that's independent. So we still have, even though we lost 350 watts of charging, we still have another 200 watts that's still topping off the system. So you have redundancy in case one of these systems were to fail. Now, we're not dealing with a lot of amps here. Typically, you could go up to 60. Same here. But guess what? You got to remember that the power cables going from your batteries to the back of the van, you need to lay that out in the beginning, because you can't just take a 6-gauge wire that has a max amperage rating of 50 and send 60 amps over it. Just because you wanted to upgrade, you're gonna have to buy more wire. Then you're gonna have to run that wire through the van. So the reason adding on a secondary solar system is so attractive is that it's just the panels, a cable coming through the van to a controller, and you plug it right into the power system. And typically the cables, they're not that expensive. They're in kits. So if that makes sense. So now that we understand that we could go higher on the DC to DC charger, we don't want to tax our alternator in our van, and we don't want to pay $2,200 for a secondary alternator. Because it's not because it wouldn't solve our problem, it's because the use case, the van's not moving. So we need to charge the van while it's not moving. And we got 5 to 6 hours of sun every day on top of the panels. I know we have more sun, but that's the range at which the sun is most effective on the panels, or that you're going to get. So let's solve that problem first. So we have a max of 30 amps, and his 150 watt panels will be producing. Let's look that up. So the 150 watt panels, this is the next thing I wanted to teach you guys. It has to do with how our solar panels rated for their amperage output. What do all those numbers mean? Because there's like 10 numbers to look at. It's kind of confusing. So on the back of the solar panel, right here up at the top, you're going to have like a little label. It's going to look like this. All right, there you go. Okay, see how that fine print on the label? Like, it's a ton of stuff. It's hard to understand. You've got max power, open circuit voltage, short circuit voltage, optimum temperature voltage, optimum current, temp coefficient P, temp coefficient V, temp coefficient I, max system voltage, max series fuse rating, fire rating, weight, dimensions, STC. It's a bunch of stuff. So where the heck do you begin? So I boiled it down to 5. Boiled it down to 5 things that should help you with your decision. So the first one in green was, what current are we working with? Okay, or like, what do we expect this solar charge controller to put out? So once we decide what that is, and that's typically based on, that's ultimately based on the wiring that you're deciding to use in your van. So you can go as high as you want. I mean, you can run 4-aught wire from your, Nation's alternator and crank up, almost 400 amps through that thing and charge, but that's really expensive. For example, if we go on Amazon, and we look up, we just want to get 10 feet of, let's see here. We want to get 15 feet. 15 feet, that's pretty close to run from your alternator to the battery system. So how much is 15 feet? Well, 15 feet of that cable on Amazon is $210. So really, your alternator, your high amp alternator is going from $22, now it's almost $2,500. Still not counting labor. So by more current, it's more money. So 30 amps is nice because you can run a 6-gauge wire, very typical. It maxes out at 50 amps. So if you wanted to run 30 amps and then you wanted to bump up an additional charge controller with a 20 amp, you could do that because this is its max rating and this is its max rating. All right, let's keep moving on. So as far as the next thing you want to look at are these this information down here. So again, let me move my face out of the way. Here is all those numbers. So like, where the heck do you start if you've never done this before? So just remember the 5 that I'm showing you. You want the rated charge current, the power input, max power input. That's how many watts of solar, panels that you're putting in and at what specific voltage. Your PV input voltage range or your solar panel input voltage range. That's very important. Dimensions are important because is it going to fit on your roof or wherever you want it? And then weight. That's just something to consider. Just be conscious of. All right. So there's our baseline. That's where we want to look. So we ignore, at the moment, just ignore everything else except for what I'm telling you. So short circuit current, I'm going to go very brief into this. I'm not going to get in the weeds on it. But we're not going to focus on short circuit current. We're going to look at optimum operating current. So this is what we can expect out of the solar panel, and we're going to use that to size the system. So in our case, we got 9.73. Well, we know that we're probably not going to get there efficiency-wise. So the good news, that's the good news, is it's very rare that it would ever go higher than that. So you do 9.73 times 2. 9.73 times 2, because we got 2 of the 175 watt solar panels. And that's going to give us about 19.46 amps. And, we could probably sneak in a third one. So 19.46 plus 9.73. So technically, for this 30 amp system, this red arc, we could technically do 3. How do we know that that's possible? So let's take 175 watts times 3. That's 525 watts. So technically by their sheet, we can't. So we could do 5 100-watt panels, but if we did 3 175s, according to their specs, 525 is more than 520. And so technically we couldn't do that. So that's why we have just 2. Well, we don't have the space, number 1. But number 2, the Red Arc system, we can only do with our current footprint up there 2 175-watt panels so that we're staying safe under the 520-watt max power input that this MPPT charge controller can withstand that's built into the unit. All right. So now we understand why we bought 2 of the 175s. So let's upgrade to the, well, let's add additional 50 watt. So we'll go to Renogy. Thank God these panels fit the footprint that I need, because I didn't want to go with some off-brand company that it would fit, but I wouldn't know about them. So the footprint is perfect. As you guys saw right here, I mean, look at that. This thing is perfect. Fits here, 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 and here. So we're doing good. All right, so we got this. Let's go down to specs. So for specs on this one, we've got maximum power 50 watts, of course. And then we want to go to the optimum operating current. It's usually got a little parentheses, IMP. And it's 2.69 amps. So let's do 2.69 times 4. That's 10.76 amps. Now, you may be saying, well, Nick, why did you get a 20 amp charge controller? Well, because it has to do with selection. So all of these up here, 100 amp, 60, that's 600, 200. The Rover 40 amp is 169. Rover 40 amp, 40 amp. Okay, so we got this one, and we got this one. So I wanted to stay with the Renogy brand. I'll explain why you typically want to stay with the brand of panel and controller. You don't have to do that. You can buy Renogy and have Victron stuff all over the place. My point is, these companies sell this stuff as kits. And so they're going to do a little bit of the homework for you. And I'll come back to this on why we chose the 20 amp. But the homework that they're going to do for you is the orange logo. The orange color. That's step 3. They're going to do the homework and say, for our controller, look at this. Notice how, so the PV input voltage range, that's the range of voltage that this charge controller can withstand. It can say, okay, I can read anything between 9 and 30 volts. Give me something between 9 and 30. I can do it. If it hits 32, I'm okay with it, but I like 9 volts and 30 volts for my PV input, solar panel input. But guess what? We go down here to the Rover that we got. Check this out. Its range is broader. We got 15 volts to 100 volts for its PV input range. Now, this is my opinion. This is not fact, but my opinion of why they do this is because if you have a company and you have a multiple range of products, if you design something that has a broader spectrum to grab, more SKUs, let's say, somebody that bought this Rover Elite can use it on essentially all of their solar panels. And why that's important is if I click on this solar panel, I'm going to scroll down and actually back up. Let's click on, that's 100 watt. Let's do this. So let's look at the 100 watt. So where's our voltage? So we got, let's see, VOC. So operating, let's say we got 20.4 and the open circuit. So 20.4. And so let's back up. Let's check out the 50 watt. And so we got 18.6, 22.3. 18.6 is the important one. So you can see a trend, 20, 18. I bet this one is really, really close. 18.9. Let's go. We got a bigger one. Let's go to 200 watt. So we got 22.6. So for example, and then if you wanted to add more panels, the voltage, it also, okay, let me back up. This is, so we don't have these in series. Where's my notepad? Let me go get that. I can have my notes, make sure I'm not telling you guys the wrong thing. There's no editing on live streams. So we have a parallel configuration. We are not in series. So if we were in series, then our voltages would add instead of our current adding, our amperage. And so this broader range here would assist us on that. All right, getting into the weeds, let me slow down just a little bit. If you guys have any questions, put those in the chat. I got a couple more things I'm going to talk about, and then we'll be getting to the end of today's stream. So, yeah, ask me those questions. I'll be happy to answer them. I actually might go over here and go over a funny. There's a comment on my Ford Raptor style grill over here on the channel. And saying that I took too long to install it, so I might react to that really quick. That'll be kind of fun. All right, so to speed this up for you guys, the green is, think of it as your alternator and your wiring going to your power system. How much do you want to spend or have potentially go into that as your everyday charging current? The max power input, that's how many solar panels that this charge controller can withstand. The PV input is the range, the voltage range that it can accept. And then the dimensions, weights, pretty self-explanatory. So to wrap all this up and get to the end of the video, these are the only 5 things that I think are important for selecting it. A lot of this stuff can get really complex. For example, this is this picture right here. On the left, this is the Red Arc manual, and this is the specification. So all that fine print you see there, it makes sense to me. I like to see all this so I know where I can go with the system. Is it gonna accept this or that? But to the regular or entry-level DIYer, it's a lot of stuff to consume, because at the same time you're wanting to be safe. You want to know that you bought something that's going to fit and you're going to feel safe with it charging when you're away from the van. Because remember, this is charging your van when you're not in the van. So this system is active when you're not in the van. And a long time ago, that's almost 4 years now, but when I first started the van thing, and I put my first solar panel on my van. Well, actually, that was only about, let's see, when I put, because I had the van, but I didn't have solar. I just had the DC to DC charger. But when I put solar on there, and I knew that thing was active while I was, not in the van, it took me a while to get used to it. But if you've got the knowledge and you understand this stuff, that anxiety will go away. yeah, so use this as a cheat sheet. Come back to this video, kind of listen to why I thought this was helpful for you guys. And yeah, so that's so at the end of the day, what we did was we went the Rover Elite because it was, you know, $99. It was the lowest amperage that we could go with. It's Renogy, so it's going to be happy with the Renogy 50-watt panels. I know the voltages work, but since they usually come in combo kits and stuff like that, it's just kind of a no-brainer. Renogy has excellent videos so that, say, Thomas is off, you know, across the whole country, you know, you get to know your van and learn about your van. And if a company has good videos, then customers can watch them and, you know, they can feel confident knowing that if they needed to repair something they and wanted to, they could. Yeah, so that in a nutshell is the difference between these two these MPPT solar charge controllers. It's also why I chose it. And yeah, it just kind of boils it down to help you guys make an easier choice on this. All right, let's get into some fun things. For some reason yesterday, I lost audio at the last 20 minutes of the stream, and I'm not sure why, because the lapel microphone that I'm wearing right now, it's on a separate channel. So it has nothing to do with the fancy mic. But hey, you know, stuff happens. All right, let me set this up, this reaction video here. I'm not going to do like a reaction video. And so the video that they sent me. Okay, let me go here first. This is from Michael. So Michael sent me a message talking about, and this is all positive. I just think this is fun. Let's see here. It was saying that it was way easier than my video shows to change out the Ford Transit grille. And so two things. Let me back up here. There you go. All right, so Michael says, way easier than this video shows. That's my video. I changed out the grill in 2020, literally 10 minutes. No need to touch the fascia. So I agree with you, but let me explain why it takes longer than 10 minutes. And he references this video. So let's see here. So this is one of Freedom Van Gogh's videos, and these guys are awesome, so nothing against them. But what I want to point out is the clips on here on the van. For me, you know, so pulling this out, it's okay if you rip it out, you know, kind of aggressively. I'm not. That's fine if you want to get it out quick. But the point that Michael was making is that you can change it out in 10 minutes. So I'm not about speed. I mean, things need to get done in a relatively good time. But if you guys watch this video, this grill is not the same grill. So Ford had a half year. So 2020, like the first 6 months, let's say, this grill. So this, by the way, this is a 2019 Ford Transit. So it's not a 2020 and up. That's when they made the change. So this grill here is held in differently than the other grill. So I will agree. My grill, this is my personal van, it takes longer to get this out. One, because I didn't want to break the tabs on my own van and have that be a problem to deal with later. Because if you break plastic tabs on a van, if you guys have ever been into auto body repair or anything like that. The worst thing is breaking off these plastic tabs that you can't put back on there. Now, guess what? This grill is only held in by plastic tabs. I actually have 2 pieces of plastic in the top left and top right that I have drilled into the plastic behind it just as a safeguard, because this is only snapped in with plastic. I mean, it could technically be ripped out just as easily as you put it in. But I take my time because, one, I'm teaching you guys. That's the whole point of this channel, is a learning channel. And number 2, I just don't want to waste my time with ripping something out and it break. And then because of me trying to, win a stopwatch race, that's all I'm saying. You guys don't think about, when you're working on your van, don't think about like speeding through the whole thing and breaking something. You just don't want to do that. For example, here is the little piece that I'm using to make sure that, where is it? There it is. So what I'm doing is I'm putting a little clip in there because the top section doesn't clip in positively on a 2019 Ford Transit. All right. Now let me go back to the comment here. So in the Freedom Van Go video, so this is a different model year Ford Transit, and the clips are different, but they're not that different. So there is still a potential to break the plastic so just be careful. It's not a race. That's there's my reaction. It's not a race. Just make sure you just take your time. And I will give you one other real important point. On Thomas's van specifically, this van in this video does not have the windshield wiper front camera controls on it. So if you imagine if I had, kind of pulled that out quickly, it's possible to damage very expensive camera and very expensive washer control motor and the feed line from the windshield washer fluid. So, although time is a consideration, it's not a race when you're doing this stuff, especially if you're DIY. So my video was long because of that. There we go. So Michael, I'll do a quick response like that. I just it's not a race. Let's go back to some more comments, because for some reason, none of this got recorded yesterday. I don't know why. All right, so we're moving down. Jamie was upset that the stream didn't happen yesterday. Yeah, I was worn out, and I needed to focus on getting those aluminum tubing, like precisely drilled out. So Mitch, the information on the AC unit, if you're on a live stream in the future, let me know if that has to do with air conditioning or like AC as the inverter. That would be helpful. Craig, I did order the bump out for the Adventure Wagon. They will provide those to you at a cost, obviously, but you can buy it just raw plastic, or they can upholster it for you, no problem. I have not done the rear of the van, so he's asking if I have done the if I put the Adventure Wagon into the panels in the rear of the van. So I've not done that. So run the equator. This comment was having to do with not knowing the price of every specific build. So that's hard to do when you're doing interviews, because you kind of want to maintain a relationship with the person you're doing the interview. A lot of these companies have no idea that I'm going to interview them. I'm just kind of having them walk me through the van. So, kind of having them asking the question about what the price is. Sometimes it's a little bit forward. And what I would have to say is, as much as you watch YouTube, you we'll start to get an idea of how much a build costs. The first place you can look as a good cheat code is just look at the power system. If they've got a massive power system, it's probably a very high-end build. Just as we talked today about all the stuff that goes into a van, bigger power system, more expensive cables, so on and so forth. And then just really zoom out and just look at the van. I mean, there's tons of exterior accessories. Typically, that's a very high-end build. But yeah, if you go back and watch this video and kind of take that as a place to start, it'll kind of help you see your price range. I mean, there was vans there, no joke. I mean, anywhere from, the DIYers, they were selling like their used vans for maybe 60 to 100,000, all the way up to close to the $300,000 range. So there's a big range, but I mean, there's a lot of expensive stuff that goes into these vans. So the Red Arc power system, that will be coming soon. You guys already saw that we've done a little bit of the Red Arc. We'll go through the whole system. That live stream is coming soon. This question was about Propex versus brass or plastic, and which one is stronger. So really, there's not necessarily one is stronger than the other. It's just the materials are different. Plastic fittings are made for plastic tanks. Brass is dangerous because you can actually break the hole that you screw in the plastic fitting to. Gotta be careful with that. Another difference is brass has a larger interior diameter because the metal is stronger. Plastic has a smaller interior diameter, and that's because it needs that room to enhance the strength. So it can be restricted, but let's be honest. If you are in a van, let me move this up. But if you're doing van life, your water restriction from the back of your van to 5 feet from your sink is probably not that big of a deal. Let's see. I think I've gotten to most of these. Yeah, we're gonna end the stream here in just a second. So guys, let me know if you have any other questions. I'm just looking through any of these that I missed. Okay, so it looks like I did not miss anything. All right, guys, couple more minutes, and let's say 3 minutes, and then I will end the stream for tonight. Let's talk about reaching out and contacting me. If you guys are interested in a custom van build, you can reach me on Odyssey Custom Vans website. So that's my company, Odyssey Custom Vans. Go to the contact page, fill out the contact form, and be happy to hop on a phone call to talk about your future build. In the message, tell me about your story. Why are you getting out there? Why are you doing either the van life or you're traveling? Or you're using the van for other purposes. Tell me the story about where you're looking to go and what you're looking to do. I'd be happy to start that conversation with you. Also, until I get it up, I'm going to keep saying this every stream until I get the consultation link up. I will be doing phone consultations, so you can schedule time with me to talk on the phone about specific questions that you have on specific things. So you can actually book a time with me. Until that comes up in the next couple weeks, this contact form can be used for that. So in the subject line, just type in consultation, and then the message, what you want that to be. And then I'll reach out and we can talk one-on-one on the phone instead of kind of doing it through the live stream. So I'm here to help you guys. I do these live streams as many times as I can throughout this week when I'm working on different builds in the shop. As soon as Thomas's van is put back together and out of the shop, our spec build will be coming back in the shop. We'll be working on it. And so our goal is to get that one knocked out before the Adventure Van Expo series kicks off, and that van will be ready for sale. But the cool thing is, until now and the sale, you guys will get to see all the components and products that we put into the van, how we did it. Heck, you might even be a part of the process as far as me changing my mind on what I want to do with the van, which is, I'm thankful Thomas's van is in here because I've gotten to brainstorm a little bit about what I'm doing on that van instead of just like kind of doing the whole general spec build. But anyway, guys, thank you so much for staying to the end of the stream. Always here to take your questions. If you have any questions or comments, put those in the comment section below, and we will see you guys in our next live stream.